Okay, this problem came in Jee Main 2024 in January shift. So there is a complicated circuit is present, and the battery has electromotive force 2 volt and internal resistance is 2 by 3 ohm. The power consumption in the entire circuit. So to solve this, we have to firstly reduce this complexity of this problem. Okay, so how to reduce the complexity? Just from this 1, 2, 3, 4, 5, 6, if we find out the equivalent resistance of this circuit, which is coming from 6 resistance is present in the circuit, we can easily find out the power consumption in the entire circuit. Okay, so firstly we have to calculate, or we have to find out the equivalent resistance. So firstly see that this 2 and this 2 ohm is in parallel, because they are between their endpoints, this and this, no resistance are present. Similarly, this between their resistances endpoints, this 2 ohm resistance and 2 ohm resistance, these endpoints, this and this, no resistance present. So these are parallel, and similarly these are parallel, and all are 2 ohm. So what will be the equivalent circuit? Okay, so this is 2 and this and this is 2 obviously, and there is the battery, and internal resistance of the battery is 2 by 3. Okay. So these two are in parallel, these two and this resistance. So equivalent resistance between this 2 and 2 resistance, we find out this in parallel. So this is 1, so this is 1 and this is 1. Okay. So what will be the equivalent resistance? This 2, so this one again, this is 2 and this 2, all are in parallel. Okay, so equivalent circuit is 2, this is 2 and this is 2. Okay, and this is the battery, and this is 2 by 3 internal resistance. Okay, so these two endpoints are connected in same point, and no resistance present between their endpoints, this end. Okay, so this 2 to 2, these 3 resistances are in parallel. So equivalent circuit will be, so this from these 2, 3 resistances, their equivalent resistance will be R1 by R is equal to 3 by 2 from these 3 resistances, because they are in parallel. So R is equal to 2 by 3. So my simple circuit will be, this is 3 by 2 and this is battery, this is, okay, so internal resistance 2 by 3. Okay, 1 second. Okay, sorry, this 1 by R is equal to 3 by 2. So R is equal to 2 by 3. Okay, this R is equal to 2 by 3 ohm, and this internal resistance is 2 by 3. This 2 by 3. So total equivalent resistance of the circuit will be this 2 by 3 and this resistance. These two resistance are in connected in series, because their endpoints are not connected in same point. Okay, between their endpoint a battery is present. Okay, so our equivalent is equal to 2 by 3 into 2 is equal to 4 by 3. Okay, so power consumption, totally power from the circuit, V square by R equivalent what is the V given? V is the 2 volt. So 2 square is equal to 4 and R equivalent 4 by 3. So this is 3 watt. Okay. So the power consumption in the entire cycle will be 3 watt. Okay. Firstly, we have to reduce the complexity of the circuit. These two resistances are in parallel. These two resistances are in parallel. So, but when they are connected, this one in series, then these three resistances are in parallel because the endpoints are connected in the same point. No resistances are present between their endpoints. So, their equivalent resistance will be 1 by R is equal to 3 by 3, R is equal to 2 by 3. So then entire circuit will be this, but this resistance and this resistance are in series. So entire equivalent resistance of the circuit is 4 by 3 and thus P is equal to this. Okay.